Okay, good day, everyone. Today we have a special talk as part of um, it's a really long name for the for the event, but it's Google Cloud Next on Air 2020. And this talk here we have Akash from Google Cloud, the Google Cloud team, and we have Arthur from the Firebase team. And here they're about basically to talk to us today about what we can use cloud for, talking about cloud from a developer perspective. So first and foremost, maybe Akash, you could just give us a rundown. What is Google Cloud?
Yeah, sure, man. Nice to meet everybody virtually. Google Cloud it started off as a platform for hosting code. It started off as this product called App Engine, and then that evolved into what it is today, which is a multi-product offering where you have everything covering from AI and ML all the way down to your traditional VMs and everything in between. Um, One of Google's claim to fame is Kubernetes, which I know what Nick want to talk about in a little bit. Kubernetes is basically a containerized orchestration tool that Google built and open sourced to everybody, and now all of the major clouds adopted it. And yeah, I guess we'll talk a little bit more about that as we get to that. But in general, Google is a cloud platform that encompasses everything from your traditional infrastructure as a service, which is your VMs, to everything more advanced to serverless, which are things like your big queries and your data analytics and your AI and ML, and everything in the full spectrum in between.
Okay, so that's interesting. Thanks for that. Um, well, I was talking with Arthur right before the stream, and one thing we was getting, well, this event is about Google Cloud Next, which is another event, and we will be showing we'll be showing the links to all of those videos to our viewers. But one thing for me, my particular experience is that some things really go over my head,
Mhm.
and I feel like maybe I'm not as IT as I think I am. I wonder if you could shed some light as to why it feels like maybe I'm not the exact target audience.
Yeah, and as to be honest, that's a common thing, right? Like the I guess the difference with Google Cloud, and even I felt this coming into Google myself. Google is an engineering company by design, right? Unlike the other clouds. So the way that our documentation was, the way that our tooling is designed, all of those things are built purposefully with the assumption that there is some level of um, there's some competency of the particular technology or product you want to use coming into the cloud. So it doesn't really allow you to start off at the 100 level or the entry level and kind of build your way in. That has since changed over the past year, and we have done a lot of work in our public documentation space, especially to help people come and adopt the cloud. Because the reality is, cloud is a buzzword, right? You hear everybody saying, "Oh, I want to go to the cloud and I want to use AI and ML and I want to develop this mobile app." But the reality is, you don't know how to start. You don't know. There's so much information out there that you end up in a state of analysis paralysis where you don't know where to begin and you don't know how to begin. So a lot of the focus that we've been doing this past year is really just helping people come into switch mindsets into like, I am new to the cloud. How do I get started? How do I spin up my first VM? How do I build my first Kubernetes cluster? How do I deploy my web app? How do I build a web app? Like just walking through those basic fundamentals and helping enable everybody to use or to consume cloud services as much as we can. And that's really the big drive that we have been doing this year to really just help enable everybody to use the platform more efficiently.
Okay, yes, it's good. It's interesting that you mentioned this word, this buzzword. Another thing, me as a developer, right? So I develop small apps, consumer-facing apps. Another buzzword I always hear is enterprise.
Mhm.
And then when you have to build an enterprise app, there's certain things you can't use. Can you shed some light of what's the difference between an enterprise and like a consumer app?
Yeah. So an enterprise is, if you think in a traditional sense, right? Enterprise companies are these big beasts of a company. So back home, you think of a small mom and pop shop, or you think of like a small computer parts store that sells a very specific product set, and they do a little bit of computer repair and a little bit of virus cleaning and so forth. They are your traditional small to medium sized business. But then you have the larger companies that have business processes, that have traditional workflows, that have some type of change control built in, some type of formal structure within their business process. And that's where you have companies like the telecom companies, the utility companies, like all of these big, massive companies. And when you think of an enterprise app, you have to think of the workflow associated with it. So something that might fly for a consumer app is, let's say you want to just send a text message, right? Let's say I'm building a text message app to communicate, like I'm building the next version of WhatsApp. If I build an app for consumer or a smaller business size, or like a general consumer population, I might just say, okay, all my app needs to do is be able to send a message from one person to the next person, end the story. But now when you start introducing the enterprise piece of it, you have to start thinking, okay, well, how does that message go from one person to the other person? Is my message secure? Is my message, can somebody fake my profile to send a message on my behalf? What is the accountability? What's the auditing? All those different types of components that you traditionally wouldn't have. And that's the methodology that you start to inject into your application framework, and building those things, and then building that functionality into the app itself. And also now being able to, when you start having to introduce that type of functionality, you also have to start now leveraging concepts like CI/CD and unit testing, those kinds of things. So that's how it branches out into a normal small little project to do a simple app into a more full-scale application that has multiple facets and multiple technologies to support it.
Yeah, as an example of that, some of my team members worked on some of the apps that some of the government organizations were using around the US for on tracking unemployment. And so, from a technical perspective, the apps weren't very complicated at all. They were just really, they were forms basically. But you had to have things like, how does the government agency authenticate? That was a big deal for us. So it was like they wasn't signing in with Google or signing in with Facebook or something like that. Like they had their own type of credential management that had to follow certain rules and regulations, and then we had to be able to interact with them. So I think some of that is where, when you're dealing with that on that enterprise level, you just have a lot more boxes to check other than just, does it work?
Yeah, exactly.
So
it goes from a Hello World app to like an actual production level app.
So it seems to me one of the big words, one of the key concepts is scale. So it's so many customers or so many users, or maybe your user has users. So maybe a simple VM doesn't cut it anymore. So I think that's where you need this additional infrastructure, which I guess you would rely on the cloud for. And speaking about VMs, I know that's just one way. There's one kind of compute resource. So I know that cloud has many different kinds of resources. And as a developer, I know what a VM is. I could go on, these other small providers, get a small virtual machine. I could put a little website, and that works fine. When you're scaling out and when you're using like Google Cloud, for example, I see in the compute section, there are other options. So maybe we could spend some time talking about that. I see that you showed me this, give me this handy diagram. Let's see if I could put this on screen. If you could just spend some time talking about this a bit. Okay.
Yeah, sure. So I'll be looking on my monitor because I can't see too well on this one here. So
okay.
I'm just going to talk through, go left to right on this one, right? So on the left hand. So before I start, this is what we call a GCP sketch note, and this is a new concept that we have. One of our developer advocates, Priyanka Vergadia, she's one of our developer advocates, and you can see some of her videos on YouTube and stuff covering different topics, especially in the developer space. So she put together this sketch note, kind of covering all of the different compute options for code, or specifically for developers, and kind of helping you identify where your what compute best addresses your need and what you're trying to do, right? So on the left-hand side, you have Compute Engine, which is your traditional VM. This is the simplest, the most common type of deployment that you would have. This is what everybody's accustomed to. You spin up a server, you run your binaries, you put your particular compilers and so forth, and you build your app, you run your app, you host it, you do all your dev work there, and good to go. The problem with that is, on top of you being a developer, now if we're approaching this from the developer context, you as a developer, you now have to worry about, is my server secure? Is my server patched? What's going to happen if my server go down, to the point of scaling? Oh shucks, I just realized my 10 people who was using this app, they posted on Facebook, they posted on our WhatsApp group, and now 100 people using it now. And this one server can no longer take that weight. So now I have to go and quickly try to spin up a next VM, rebuild everything, and try to put this together, put load balancer in front to make sure it's working. So like this now becomes additional overhead. And as a developer, I may or may not have that skill set to say, I can do this readily. So while it is a great option and an easy press button go, it's not exactly the best fit for everyone. Kubernetes, on the other hand, and actually Kubernetes and Cloud Run. The concept of containers. What I like about containers is it allows you to be completely portable. And when I say portable, I mean that in every sense of the word. So you can, on your own personal machine, at home, use something, use like Minikube or some version of Kubernetes, or I'm sorry, not even Kubernetes, some version of Docker, build a container, build your app, do your front end, do your testing and everything. And once you have that container built and you have that stored in a registry, you could literally just go to any other provider. You could go to Google, to Amazon, to Azure, to anybody that runs Kubernetes, and you could run that same app on your Kubernetes cluster, and it is going to work the same way as it would on your laptop or wherever you develop it on. And that's the beauty of containerization, right? It packs all of the dependencies to run that application into one very nice, small, lightweight box that can run anywhere. And the major benefit of containerization is, as a developer, I don't have to worry now about what the underlying infrastructure is. If I'm using something like Docker Swarm, or I'm using something like Kubernetes, which we would obviously prefer Kubernetes because it's much more mature and much more widely adopted. Kubernetes would take care, once you configure your settings of how you want that app to run, Kubernetes could take care of everything for you. So what that means is, let's say in your application configuration file or in your Kubernetes deployment file, you say, I want this app to have at least one container running, meaning I want one instance of that app to always be available regardless of who using it. Regardless if it's one user or 100 users, I want a minimum of one user. And then within that, you set thresholds. And you say, let's say, if I notice a spike of CPU, or I notice a resource contention, or whatever the case is, I want to now be able to, I want the system to automatically add resources to compensate for that additional load. That's where the scaling part comes in. And not to switch gears, but you can also do scaling in Compute Engine as well, but that is also a very heavy process, and I'll kind of circle back to that if we have some time. But within the containerized platform, when you say you want that to scale, the system will automatically, without you having to wake up 2 o'clock in the morning, realize that, okay, I'm seeing a lot more increased load coming into this container. Let me add 2 or 3 more containers based on the configuration of your application deployment to absorb that load. And the great thing about scaling is, when that load spike has gone, those containers will be discarded, so that you back with your original one. So not only does it help you absorb that load coming in, it also scales back down to save you cost, because as you increase resources, you pay for that, but then as you scale back down, you don't.
So just if I can talk about containerization,
Mhm.
because maybe not all viewers will be not know much about this topic, but so I know VMs is a virtual machine, is a way of creating like an isolation on a server, so many users can have a VM. I think, can you say like a container is like one step further of virtualization, such that you can run many containers in a VM?
Yeah. So I'm sorry, I should have started off with this. So your VM, whether it's a physical server or a VM, you have a few layers, right? You have the kernel, then you have the operating system itself, then you have your application. Even before the application, you have your dependencies that you need, your different libraries and so forth, and then your application on top of that. So you have 4 layers for all intents and purposes. If you were to scale that, and going back to the compute engine, if you were to set up that as a scaling, every time you scale and you build a replica on top of the application, you're also going to have those additional 3 or 4 layers below that will be coming. So every replica you have will have a kernel, an operating system, the dependencies, and then the application. So that quickly becomes very heavy and very bloated. A container basically does virtualization at a different level. What it does is you have a shared kernel, a shared operating system, and then the dependency and the application sit within its own isolation box. So what that means is that once you have a system that meets the minimum requirements for containerization, you can move that application to any other system that has a kernel and an operating system that can support that, of course. And your application will run because you have the dependencies there and you have the application there already, and there's no additional work needed to build it.
Yes, I just did a quick Google search, and I think just to add some visualization to what you're saying.
Yeah, exactly. So on the right hand side, those binaries and the libraries is the dependencies I was talking about, and then the application that sits on top. So what a container would do is a container would take the application. So like looking at the green box on the right side, a container would encompass application 1 and the binaries and libraries associated for application 1. So then you could take that app 1 now, and that container that consists of app 1 and binary library app 1, and move that to any other host that supports containerization, and that application would run just as if it was on the original machine.
Right.
And that's the beauty of containerization.
Right. So, but with the Kubernetes, I would guess all of these containers would have the same app.
Not necessarily.
Okay.
So containers is in the context of Kubernetes specifically, you have this concept called a pod. A pod is the smallest identifiable unit within Kubernetes. The pod has the container within it, but a pod can contain multiple containers. So you can have let's kind of make this a little bit more simple, right? Let's say this application here is a website, right? So you have a website. Let's call it gdg.tt. So the gdg.tt is this website that you build here, and you have your associated binaries, and you have that packaged together nicely in a container. In Kubernetes, you could have a GDG pod, but it consists of the gdg.tt website container, which will be that there, but it can also consist of having a SQL Server, for example, a SQL Server container. So that pod now becomes an entire, it contains multiple containers, but they all serve the same,
kind of logical purpose.
Exactly.
Yeah, okay, interesting. But when you're speaking about the auto scaling, right? I would imagine it would create containers with the same, basically with the same multiple instances of the same app, and then it would look like it's one actual application to the clients who connect.
Yeah, Yep. And
Okay.
so the way that happens is what it does is Kubernetes creates, and this is all transparent to the end user, right? Like they wouldn't know the difference. But what Kubernetes does at the minimum is you could do, and I don't want to go too deep into the weeds with this, but you have a load balancer at the front that automatically gets created. And it's either going to be something called a service load balancer or an ingress load balancer. And that is it kind of out of the scope for this one. But essentially, what that would do is that gives you a single front end IP address to reference that application. So
Right.
on the back end, you could scale you could have 100 copies of that same application, or you could have one single copy of that application. But from the front end perspective, it's still referenceable by only one IP address. And when your users connect it, they connecting to that one IP and not to the individual IPs of the applications.
Right.
So that's where the scale allows you to grow and shrink without any kind of impact to the users.
It's kind of like an invisible scaling.
Exactly.
And I think, correct me if I'm wrong, Akish, but Kubernetes will also do things like allow you to have a single data source, and it will handle like concurrent requests to the same data source, and do that like be the traffic police in that case of not having somebody be able to like spend the same money
exactly.
twice.
So
or something
that's
like
where we
that.
start getting into things like namespaces and network policies and so forth. That's really like the communication between the different services. But yeah, that there's functionality like that built into Kubernetes.
Okay, so maybe we can move on to Cloud Run.
Yeah. So Cloud Run is the easiest way to think of Cloud Run is all of the great things that you get with Kubernetes, but without having to manage Kubernetes. So what this really is intended for is for developers who just want to like you have a actually before we go to Cloud Run, let me kind of talk a little bit about the App Engine and Cloud Functions, and then I'll jump back to Cloud Run.
Sure.
So now that we have a basic idea of containerization, even though there's that advanced level of virtualization and it makes things super easy to run, there's still a little bit of overhead from the developer perspective. You now have this block of having to learn Kubernetes and learn the basics of it and how to build these deployments and all of those different things, right? So sometimes that could just be overwhelming, and again, it's another barrier to entry coming into the cloud. So platform, if you look on the right-hand side here, you see there's a Your Code banner, and then it points to Cloud Functions and App Engine. And what this means is these two offerings that we have are really designed for the developer in mind. You as a developer don't want to worry about any infrastructure below. You don't want to have to worry about scaling and setting those things up and setting up thresholds. Like all of that is still still falls into the operational realm versus the developer realm. The products like App Engine and Cloud Functions serve very specific purposes because they abstract all of that infrastructure away and just give you a platform to run your code. So you as a developer can say, you want to build a Node.js app, for example, and you want to do some React in front or whatever the case is. So you spend your time, you build your React front end, you have your Node.js backend, you set everything up, you have your everything running exactly the way you want it to. It looks exactly the way you want it to. You just want to deploy that and see it run. Like that's all you want to put that in cloud and not worry about anything else. That's where App Engine will come in. App Engine is a platform designed exactly for that, and that's where Google started. Like I said in the beginning, that's the first product that Google released in the cloud. So all you do is you use the Google SDK that you would install on your machine. You would make sure you have your account and everything set up. You have your authentication and everything set up in your SDK. You take your code and you just say gcloud app deploy, point it to your folder, and then that will literally just take the existing code you have, copy it up into the cloud, set up everything for you, and then give you an endpoint and say, boom, here's your endpoint. Click on this, and then you can access your app. And it is as simple as that. And then when you do that, now depending on which version of App Engine you go with, you can, if you go with the App Engine standard, it will automatically just, it takes care of everything for you. It takes care of scaling. It takes care of making sure you have replicas and everything. Like, it just really takes all of the weight off of you. And then you get a URL that you could click on. And then if you have a public DNS a domain that you need to set up your records and so forth with, you do all of that in the backend, and then all of a sudden you now have a publicly available website that has everything. And App Engine itself is an ecosystem that contains everything you would need to run your app. So it has access to Redis or to memory store, what we call it. So if you need to have like in-memory databases and so forth, it has access to Data Store, which is a database specific to App Engine. It has storage built in. So it is a complete ecosystem for an application that you could literally just deploy your app there and not have to touch anything else in GCP if you didn't want to.
That's interesting. So I'm seeing the different, these arrows, and it's interesting because it's saying it's letting you know of the trade-offs. One gives you more control, but if it's more control, it's more overhead.
Yeah.
And when less control, less things you gotta think about. So I guess it's pick the option that you're the most comfortable with.
Exactly. And just kind of piggybacking off of that, right? Like, let's say as you build your app, right? Like you develop this thing, and over time you have multiple iterations, multiple features, people starting to use it, or you just want to add more stuff, right? But let's say there's some code in there that does not necessarily need to run all the time. Like
right.
So a real example is, let's say you have some type of intake, like you have a front-end website where a user could upload a file. And when that file is uploaded, you want your application to, let's say you want to do like a categorization, like your user is going to upload a file to you, and then you're going to use some type of logic to say, this file contains a picture of a cat, or a picture of a dog, or a picture of a flag, or whatever the case is, right? But that code that is going to analyze the request coming in doesn't always need to be running, because you don't have a constant upload of users. People not every second uploading a file is whenever it happens. So that's where Cloud Functions come into play, and this is where you have functions as a service. So a function is a piece of code that runs only when there's an event or when there's a trigger. So in this case, the trigger for you or for the app will be when a user uploads a file to the application. When that happens, you have different ways of coding that trigger. It could be a HTTP event, it could be a GCS bucket upload. You have different ways of doing that.
Okay.
When that trigger occurs, it's going to execute that piece of code only, and it's going to do whatever logic you built into that code, and then it's going to stop. And then after that, it's going to return the results of whatever processing it did to your application or to wherever you tell it to go to. So the benefit of that is you only pay for that code execution when it executes. So from a cost savings, and this is where, like, as your app starts, as you start thinking adopting cloud and leveraging cloud services, cost is one of the important things you have to pay attention to. And it's things like this, like determining your business boundaries or your application boundaries, of identifying things that can run once and then shut down, or run on demand and then shut down. Things like that help you control your costs, so that at the end of the day, you don't end up with $1,000 bill and you're like, what the hell, all I do is deploy a single app, right?
Right. So that's interesting, because even thinking about your example, maybe it's running some ML model in the background to do object detection, and maybe you need a lot of memory for that.
Right.
So it doesn't make sense to have all of those resources available 24/7 that you're paying for if you just need it for every once in a while a user is doing an upload.
Exactly.
So it really gets you to segment the functionality and provide and distribute availability and save costs.
Yeah, exactly. And so, the reason I wanted to talk about Cloud Run last, and I want to say one more thing on these two before we jump to Cloud Run. The downside of working with a platform as a service offering means that the supported languages that we have are limited to what the product supports. So, like, for example, and I forgot the versions of Node, but let's say, I think, I don't want to misquote the numbers, but there may not be the latest version of Node.js support available in like Cloud Functions or App Engine.
Right.
And you may, as a developer, say, I want the bleeding edge technology. I want to use like Python 3, for example. And that platform as a service offering may not offer support for Python 3, just as an example.
Mm-hmm.
So that's one of the downsides of using a platform as a service. You are bound to whatever languages they support on that. But the good thing is, because languages are being updated so frequently, all the cloud companies are being forced to make sure that they release support for those versions of the app of the language very rapidly. So if it's not supported today, within a month, 2 months, 3 months of general release of that language, it should be supported in the platform. But you could run into a scenario where there is, even if the platform as a service supports the language that you want, there may be a library specific that has some type of callback to the kernel or some type of specific callback that the platform will not do. Because as you rightfully said a few minutes ago, as you have more access to the operating system, there's more overhead. But as you have less access to your operating system and you have more of a platform, means you have less access to the underlying components. So you are, because of it's a secure boundary, you can't really necessarily access every single thing you could traditionally do on a compute engine where you have full access to the kernel and everything like that, right? So this comes into play, like the only example I can think about is in like MySQL, right? There's a specific issue where you're trying to run some queries and there's a hard limit within, or a soft limit, I should say, within the application, within MySQL itself, that prevents a certain amount of queries from being run. There's a flag you could enable that it makes a kernel call back to the operating system to make that adjustment and allow you to do it. But you could only do that on a compute engine instance where you have full control of the kernel. You can't do that on a managed platform. So that's an example of like something that your application may need to do that it might not be able to do on a platform as a service offering. So Cloud Run is kind of that hybrid in between. Cloud Run allows you to do the same thing of it, and it's properly positioned in the middle. It gives you access to a lot more components in a language or in a server or in a operating system than you would traditionally get in a platform as a service offering. You still don't have full kernel access because there's a security boundary there, but you have a lot more flexibility where if there's a particular library or there's a particular dependency or there's a particular function or some type of code that is not suitable for App Engine or Cloud Functions, and you don't want to go and have to learn Kubernetes, Cloud Run gives you a container as a service essentially. So you can go ahead on Docker, you could build, you follow the same methodology, you build your application, you make sure you have all your dependencies and everything set, and then you just run that in Cloud Run. Now, Cloud Run runs on something called Knative. Knative is an open source project that Red Hat and Google and IBM and Pivotal and a few other companies, I forgot the others, they contributed to. And what it does is it introduces something called a primitive. And a primitive is a building block in Kubernetes. And the easiest way to think about it, or to think of a primitive is, like let's say you're building a house. Your foundation that you put down is going to be Kubernetes, right? Mm-hmm. Or your infrastructure, let's say. And the framing of the house, when you pop your bricks and you do the wood framing and all of that, that is Kubernetes. That's going to keep everything nice and safe and secure. Your car that after you build your house now, you want to take your car and you want to drive and put it in your garage, right? So your car in this example is your container. So you go, you put all you get the car you want, you customize it how you want, you add your little rims and so forth and whatnot, and you drive that into your garage and you use that as your application. But nothing's stopping you from taking your car and carrying it by your partner house to go online, or nothing preventing you from taking that car and going to watch a movie, or, well, I mean, now with COVID, you have a little bit of restrictions, but I mean, conceptually, nothing preventing you from driving your car to go somewhere else. And that's where Knative comes in. Knative is that library that runs on Kubernetes, and it allows you to take those applications that you will be running in Cloud Run and move that Cloud Run container into Amazon or into Azure or to on-prem or anywhere that you run Kubernetes that has the Knative primitives. So it's just an interface that allows the application to interface with Kubernetes and really embrace that serverless type of methodology. So it's, I guess let me kind of pause there because I kind of cover a lot of information. So let me save a little bit of space for some questions.
Okay, so the way I'm getting it is Cloud Run is another way to go about with VMs, containerized applications, but you don't have to think about Kubernetes as much
at all.
Okay.
So there's this concept called serverless, right? Serverless serverless is a misnomer because ultimately the code or whatever you're doing, it still runs on a server in the backend. But the term serverless basically tries to abstract everything below the application level down. So as a developer, serverless is one of the great attractions to cloud because you as a developer just want to place your code somewhere and you don't want to worry about nothing else.
Yeah.
Cloud Run, and that's exactly what App Engine is. App Engine is just a place to go deploy your code, and then you don't worry about nothing else. You don't worry about any of the underlying infrastructure. You don't have to worry about having multiple copies for redundancy and backups, and all of that is taken care of for you.
But you have to worry about but you have to only use the dependencies that are available in App Engine and Cloud Functions.
Yeah, exactly. And Cloud Run just basically extend that so you have more flexibility with your language, but it also gives you the benefits of serverless, where you don't have to worry about setting up Kubernetes or anything like that, but you have the flexibility of what Kubernetes brings to you. So does
that mean you will need to install or at least set up your container to know what dependencies your app will need?
Yeah. So when you build your Docker container on your laptop or wherever you build it, when you do the Docker file, you would have to set up all of that or declare whatever your dependencies are going to be, and then your application code will then sit inside of that.
So question, I am a little familiar with Docker, and you could create a Docker file. So say I create a Docker image, what will be the difference in using that Docker image with the Kubernetes engine versus with Cloud Run?
So the only difference is with Kubernetes, you will have to, in addition to deploying that container, you would have to do something called a deployment file or an application deployment file. And that's where it's a YAML-based file where you have to declare like the pod names, and you have to declare how much replicas and any security context. So like that's where the operations piece of it still comes in. So there is some overhead and a learning curve to having to understand Kubernetes. Even if you go with like a managed Kubernetes offering, like for example, if you go with Google Kubernetes Engine, which we manage the infrastructure for you, you still, when you're deploying your app, have to configure that deployment file to run your container. So there is still a learning curve there. With Cloud Run, you literally just run your container. That's all you have to do, and we take care of everything else for you.
What is the trade-off between, because I know all of these have trade-offs, what's the trade-off? What do I lose by using Cloud Run over using Kubernetes? If I'm a Kubernetes expert, what am I giving up if I use Cloud Run?
So it depends on the use case, right? There is the easiest one that comes to mind is well, there are a few. The customizability of the interactions in namespaces. So a namespace in Kubernetes is a logical grouping of resources that serve a particular purpose. So if we go back to the original example, we were talking about the front end for GDG.TT. A namespace in this process might consist of your web front ends. It may consist of your applications and your SQL servers. Let's just say, right? So that namespace within Kubernetes will be will basically be your for the GDG.TT app. In Cloud Run, because you're just deploying the container, you don't have as much. You still have flexibility to configure like which what access it has. It's just you don't have the level of control that you would typically have with like your network policies and with like your more advanced configurations in Kubernetes to basically say, I want this app to run in this particular way as if I was running in Kubernetes. You do lose advanced capabilities by moving to a managed service like Cloud Run, but you gain the ease of use because you don't have to worry about managing that underlying infrastructure
Right.
and managing those different policies and so forth to get thing up and running.
Right. So it seems that some decisions you may have in running it is made for you in Cloud Run, and then Kubernetes would still give you the flexibility to decide on your own.
Yeah, exactly. It's an
Yeah.
opinionated way of us helping. We just want to make it easy for you. So
Okay.
when providers make things easy for you, there are some certain assumptions that are made,
Treated.
and those assumptions may not necessarily align with how you want things to run. But as a starting point, it's a great resource to get into cloud and to get to run and to play around with the technology. And more often than not, 80 to 90% of developers will find that platform as a service offerings provide the level of functionality they need for their application. There are those certain use cases where you really need to have some type of control, or there's some like a very real scenario where you would pick Kubernetes over Cloud Run is, let's say, as an enterprise company, your security team says that I need to have certain security policies in place to ensure that traffic can only communicate from one spot to the other spot and nowhere else. While you can accomplish that to some extent in Cloud Run, you cannot you can't get the same level of flexibility as you would in a traditional Kubernetes cluster, where you can go in and declaratively say, this machine or this pod or this namespace could communicate with this namespace, and I could control that on my own. So there are some trade-offs, and it depends on the business requirements. But from a developer's perspective coming into the cloud, you would always want to target the platform as a service, because that's going to be your easiest way to get into the cloud and to get an understanding of how cloud technology works. And then from there, if your requirements, if the requirements of your application grows beyond the scope and the capability of the platform as a service offerings, that's where you would
Hey, I
start.
think the audio dipped on my end.
Oh, you can hear me now?
Hello?
Yep. Can you hear me?
Can you all hear me?
Yeah, can you hear me?
Yeah, we can hear you.
Strange. Arthur, can you hear Akash?
Yes.
Okay. Akash, can you say something?
Yeah, what about now?
Well, I would assume that it would still be on the air. So
Should
my
be.
next question would be, well, actually, I think, okay, so that's a really good overview of compute. You want to talk about any other products in GCP that would be, developers may be interested in?
Yeah, so AppSheet is, I know we talked about that at the beginning as a potential product to talk about. It's a pretty new product to GCP, so I don't have too much context about it, but my understanding of what it does is it gives you a low-code interface to basically build workflows between your products. So it's a GUI-based tool that you can build your different integrations and your customizations to build some type of workflow or application front end without having to go in the back end and type up code and build specific APIs and that kind of thing. Like that, the point of it is it's already pre-compiled code that you just drag and drop to accomplish a specific task.
Okay. One thing I've came across is Anthos.
Mhm.
Can you talk a bit about that?
Yeah. So Anthos itself is a fairly complex topic, but the real value of Anthos comes in for enterprises and for people who run Kubernetes in multiple locations. So the easiest way to think about this, let's say you are a developer, or your company comes to Google and says, I want to use Google Kubernetes Engine, which is the managed version of Kubernetes, and I want to deploy my code here, and I want to deploy my containers, and I set everything up, and I love the way it's working, and happy with the experience. But then for another reason, the business may say, hey, you know what, we need to deploy another Kubernetes cluster on-prem in our data center or in our office. But I want to be able to have that centralized visibility. That's where something like Anthos will come into play. So if we focus back on Kubernetes Engine, Google Kubernetes Engine, and we go back to that scenario where we have one namespace could only talk to the other namespace, but it can't talk to the other namespace, or you have like certain restrictions in place. Or another real one is, let's say you have your development team and your production team. You wouldn't necessarily want to have your development team who will be doing disruptive changes to the application to test different things to also have access to the production team, because sometimes mistakes happen, human error, and this a developer team might release some new function that just completely breaks the application, and they may inadvertently select the production application, and when you do that, you just take down your whole business, right? So there's some boundaries that you set up, and let's say for the security team or even your local operations team says that we want to build certain restrictions in how different applications can communicate to each other. And we also want to build restrictions into who in my business or who in my team can access which resources. So that template now can be very complex very quickly. As you start adding different variables and different environment changes and different restrictions, it can get very, very messy very quickly. When you say, and then the business says, hey, you know what, we actually need to build this on-prem in our data center or in the office as well, and we need to replicate this one for one. As an operations man or woman has to go in now and make sure you copy that configuration from Google Kubernetes Engine and replicate that one for one on the open source version of Kubernetes. Because keep in mind, Google has it when you run a managed version of Kubernetes anyway, it's that particular provider's opinionated version of Kubernetes. Like they make their own customizations and their APIs and so forth. For the most part, it follows the same structure as open source Kubernetes, but there are some minor modifications that can be made. So now your business is telling you in your data center or in your office, you have to run this open source version of Kubernetes, which is a pure version of Kubernetes that may or may not have the same functionality as your managed offering in Google Cloud. You as an ops person have to now translate those restrictions and policies and so forth onto that on-prem cluster and make sure that everything is working the way it should. And guess what? As soon as you do that, the business comes and says, hey, actually, we have this customer who says we have to use Azure. They don't want to use Google Cloud. We have to deploy this thing in Azure, but we need the same setup in Azure. Guess what? Azure has a managed version of Kubernetes as well, and they have their own customizations. So now you as an ops person have to maintain Google Kubernetes Engine, you have to maintain open source Kubernetes, and now you have to maintain Azure Kubernetes. And that now becomes, it's a nightmare, right? Because all it takes is one mistake and you could just blow away the entire configuration. And this is where the beauty of Anthos comes into play. Anthos is a single management interface. So you would still manage it from the Google Kubernetes Engine webpage or the console, but it ties into the on-prem database, on-prem Kubernetes cluster, the open source cluster, and it also ties into the Azure version of Kubernetes, or where we would deploy our specific version of Kubernetes in Azure, in the Azure data center. And you manage all of that from Google Kubernetes Engine front end. So when you deploy a policy, a security policy, or a restriction on who can use what access and whatnot, that access is transient across all of the clusters. So from a management perspective, it solves so many problems because you now have one source of control and one source of authorization and access management that you could control across everywhere you run Kubernetes. And then from a developer's perspective, especially, the reason I called out having different APIs when I was talking before is when you deploy your app, if you are, depending on how advanced you get into Kubernetes, you may want to leverage certain types of features and functionalities within a managed version of Kubernetes, or even the open source version of Kubernetes. But the APIs might be different. So in your code, you may have written your application to reference the Google Kubernetes API, but those Kubernetes APIs may not work in the Google Kubernetes API calls may not work in the Azure Kubernetes calls. And that obviously is going to cause a problem, because now you have to maintain multiple versions of the APIs, you have to do environment checks, and it just becomes overwhelming for the developer again, because now you have to worry about infrastructure and not just build your code.
You could give an example to one of those API calls that might be different from Azure to manage to open source Kubernetes?
Nope, I have no idea. Well, I mean, there are some, but I don't, like, I'm not that deep in the developer space to know, like, to give you like an actual material example. But it is a real type of issue, right?
Yeah.
But the benefit of it is with Anthos, when you deploy that Anthos setup, you have one set of APIs. So when you build your application, you are referencing that one set of APIs, and it doesn't matter if you run that container in Azure, doesn't matter if you run that container in AWS, doesn't matter if you run it on-prem or in Google Kubernetes Engine or somewhere halfway across the world in somebody's data center. It doesn't matter where you run it. Once it is managed by Anthos, it adheres to a single set of APIs, which is where the tagline of Anthos comes in: build once, run anywhere. Okay. So it really, from a developer perspective, makes it super simple, because you get to focus back on your job as a developer, your passion as a developer of building an application and letting it run wherever it runs, and let the operations folks deal with managing everything else.
Okay, that is great. I think we had a really great session. Covered a lot of stuff in compute and other products that's available in Google Cloud. I want to say thank you again, Akash and Arthur, for enlightening us here at GDC POS. It's always nice to talk to Trini Googlers and connect, and so we can learn more about the technologies and the platforms that are there. Any last words from either of y'all if you want to say before we wrap up?
Yeah, I mean, feel free to look me up on LinkedIn if you have any questions. Nicholas, you have my email. Please share it with everybody. But yeah, I mean, any questions, any concerns, you want to learn more about GCP, you want to have a more specific conversation about a particular technology, you want to get some training, whatever, please feel free to reach out to me, and I will try to do my best to help you.
Yeah, I think it was useful. Thanks for all that context, Akash. I learned a lot as well. I want to point out, like, Firebase is also connected to GCP as well, in the sense that if you use Firebase, the functions that we use in Firebase are actually the cloud functions that Akash was referring to. So a lot of the same ideas come about because Firebase is so tied to GCP. But another thing I wanted to point out about containers before we go was just the idea that in deploying to production is one way in which containers can be useful in terms of using it with Kubernetes and things like that. But also the development process could also be used with containers. So if you and your team working remotely, as a lot of us doing now, like, having that consistent environment in which everybody developing in is also an option for using containers.
For sure. So thanks again, guys, and that brings us to an end towards this session. So